Okay, part 4 of the lesson is about power and efficiency. In order to understand power, let's take this example. We have two weightlifters, Bob and Jim. They are in a competition and they have to lift a mass of 100 kilogram 2 meter above their head. So we know that when Bob or Jim will exert an upward force on the weights, and the weights will be displaced with a specific distance, we know that because of this force and we have a distance, so work is done by them. Now we also know, we took before that, when an object is lifted above from the ground level with a specific height or distance, this means that the object will gain an energy called gravitational potential energy. Now the moment this object is released, we know that the gravitational potential energy will be converted to kinetic energy, and so the weights will fall downward. Okay? Now we don't need this part. We just want to know what is the work done by Bob and Jim. So by what we just analyzed, we can say that the work done is equal to the gain in the gravitational potential energy. And the gain in the gravitational potential energy is equal to the mass multiplied by the gravity multiplied by the height at which the object was displaced. So we will multiply 100 by 10 into 2, and so we can state that the work done by both Bob and Jim is 2000 joules. Now, it is a bit confusing because we want to know which one will win. So we need to find or to compare another factor other than the work. We need to take into account other factors than the work in order to decide which weightlifter, Bob or Jim, will win. So in such case, it would be very fair or accurate in order to get the winner to take the time, to measure the time Bob will take to lift this 100 kilogram up with a 2 meter height. So yeah, now that we know that Bob took 10 seconds in completing the work and Jim took only 3 seconds in completing with the work, we can then say that the winner is Jim. Okay? So we can state that the weightlifter who took less time in completing the work is more powerful. Okay, so this should make us jump to the definition of power, because in physics, power is the measure of the rate, the time at which someone or something does the work. So you can see how the three variables here are power, time, and work. So in order to find the relationship linking them together, let's analyze the example that we have. You can see that the less time the person will take in completing a work, then the more powerful he is considered to have, or the more power he considered to have. And the more time we have in completing a work, the less the power. So you can see how power and time are then inversely proportional. And so if I want to rearrange them in a formula, this should be P equals to the work upon the time. Now, since the work is in joules and the time is in seconds, so power is in joules per second. This is represented in physics in watts. So power has two units. It could be joules per second or it can be in watts. Okay? Now, we could state who's the winner by doing the general analyze. Now let's calculate the power of Bob and the power of Jim and prove it using numbers. Okay, so the power of Bob is the work that Bob did upon the time he took in completing the work. That's 2000 over 10, so that's 200 watts. And the power of Jim is equal to the work upon the time, so it's 2000 over 3, it's 666. Okay, now let's do some direct application for the formula that we just learned. We need to calculate the power for a light bulb that uses 40 joules in 4 seconds. So the work is given in joules and the time is given in seconds. So we can first state the formula. P is equal to work divided by time, and then replace the work by the 40 time by 4, and you'll get 10 watts. Second question, calculate now the energy used by a washing machine of power 800 watts in 30 seconds. So now we have the power, we have the time, we need the work. So we rearrange the formula. We can say that work is P multiplied by T. And so the formula is 800 times 30, we'll get 24,000 joules. Okay, now third question, we want to get how long will it take a light bulb of power 40 watts to produce 80 joules of energy. So you can state first the formula by saying we have the work, we have the power, we need the time. So the time is equal to the work divided by the power. And so we can replace work by 80 and power by 40, we will get 2 seconds. Now for a more challenging questions, we have a man that lifts 10 kilograms through 5 meters. We want to calculate the power in 10 seconds. So first thing, you can see here how we have the mass and we have the distance. So we don't have time, the work. We have also the time. So we do have the time, we don't have the work, and we need to get the power. So first thing, we start by stating the formula. Power is equal to the work divided by the time. Now we need to find a way in order to find the work using the given in the question. Okay, so the formula of work that we already know is work is equal to the force multiplied by the distance. And since this man is lifting, so in order to be able to lift a weight, this is the weight, and this is the object, and it has a weight. So in order for the man to be able to lift this weight, we know that the man needs to exert an equal force in the opposite direction in order to lift the 10 kg. So we can say that the force needed to lift the 10 kilogram is equal to 10 multiplied by the gravity. So that's the mass multiplied by the gravity. So it's 10 multiplied by 10. That's 100 Newton. So the man needs to exert 100 Newton in the opposite direction of the 100 Newton downward in order to lift the object. Now this man will lift the object 5 meters. So now we have the force and we have the distance. We can easily get the work. So the formula is work is equal to force multiplied by the distance. That's 100 times 5. That's 500 joules. Now we can take this in order to use it in our formula. And so power is equal to 500 upon 10. That's 50 watts. Now to more challenging questions, we have a car engine that has 250,000 watts, and we know that it's pulling the car with 2,000 newtons. So we have force, we have power, that's power, and that's the force. The question is, calculate the velocity. Okay, how is this even possible? Again, always start by stating the formula. So power is equal to the work divided by the time. We know that the work is equal to the force multiplied by the distance divided by the time. So, is there anything familiar to us in this equation that we just have? Yes. So as you can see here, distance over time, this formula represents what? Distance over time represents the velocity. This is something we took in Unit 2 this year. So our formula can become power is equal to force multiplied by velocity. And so we have the force, we have the power, we can get the velocity by rearranging the formula. Okay? And that's the answer key. So yeah, V is gonna be equal to P over the force. So 250,000 over 2,000, that's 125 meters per second. If you don't know how to rearrange the formula, then remember that you can simply convert any formula that we know into a triangle. So P is the multiply F and V, and P is over there. So we need what? We need V. V is gonna be equal to P divided by the force. Okay?